Welcome back to our numerical analysis series. This is the third and final video on the iteration method. In this session, we will walk through a detailed illustration of the iteration method. Before diving into specific problem, let us start with a quick recap of the procedure. To solve an equation f of x equal to 0, we will rewrite the equation as x equal to phi of x. Then we will check whether the absolute value of derivative of phi is less than 1 or not. If it is less than 1, then only the sequence will converge. If it is less than 1, then next step we will calculate maximum value of phi prime of x and denote it by k. If the error factor epsilon is given, then next step we will find 1 minus k divided by k times epsilon. After that, we will start constructing the sequence using the formula xi is equal to phi of xi minus 1. We will stop the procedure when the difference between two neighboring terms is less than or equal to 1 minus k divided by k times epsilon. Now let us see one problem in detail. Find the real root of the equation x cube equal to 1 minus x square on the interval 0, 1 with an accuracy 10 to the power minus 4. Here epsilon is 10 to the power minus 4. We will rewrite the equation as x cube equal to 1 minus x square, then rearrange it in such a way that x is equal to 1 divided by square root of 1 plus x. Thus phi of x is 1 divided by square root of 1 plus x. As we explained in the procedure, we have to find the derivative of phi, that is phi prime x, which is equal to minus 1 by 2, 1 plus x whole raised to minus 3 by 2. Clearly, this value will be less than 1 as our x is inside closed interval 0, 1. Now let us take the maximum value of phi prime x by substituting x equal to 1 in this given phi prime x. We can easily calculate that this value cannot exceed 0.2. So we will choose our k as 0.2. Hence, what we have to check is this difference between two neighboring terms, that is xn minus 1, its absolute value should be less than or equal to 1 minus k divided by k times epsilon, that is equal to 0.0004. That is, we will stop the procedure when the value terms of the sequence, the difference between two neighboring terms of the sequence is less than or equal to 0.0004. For iteration method, we will start with a random number x0. Here we will start with x0 equal to 0.75. Then x1 will be 5 times 0.75, which is after calculation you will get 0.75593. Immediately you can calculate the difference between x1 and x0. Since it is not less than 0.0004, we will not stop the procedure. We will continue to calculate x2. x2 is 5 times 0.75593, which is equal to 0.75465. Similarly, we will calculate x3. But at this stage, we can find the difference between x3 and x2 is less than 0.0004. So we will choose our root as x is equal to 0.75493, which is actually your x3. Now you can try these problems yourself. Thank you.